right, folks, it looks like most people got a good start on this problem. So first, there are 3 function pieces, so we want to make a table for each of those pieces. And again, strongly recommend labeling those with the equations themselves. That way you will find it easier when you are plugging in those input values. So starting with our bound statements, we've got a bound value at 1, so we're going to have a bound line at 1. Always vertical, always dashed. We've got 1 again, so same bound line. And then 3. And then 3 again. So now we have broken it up into 1, 2, 3 areas of the graph. So 1 area for each function piece. So looking at our first function piece, we're going to be this function if x is less than 1. So what value do we start this table with? 1. But how do we show that that value isn't really included because it's not less than 1? We use an open dot. And folks, again, what is the point of the open dot? It's to show you where I stop being one function piece and start being the other function piece. So I always need a placeholder on the bound line for those values that aren't included for the inequalities. So 1 with an open dot. Folks, I'm going to turn you loose again from here. Get as far as you can. Once you're done choosing your inputs, you can take a look at these tables up here and make sure that you went in the right directions for those inequality signs. Less than -1, between 1 and 3, and greater than 3. And now we plug those inputs into our equations. 2 times 1 is 2, plus 1 is 3. And once you've filled out those tables, practice drawing the lines. Be very conscientious of those open dots, especially if you are using pen and can't erase very well. So make those open dots nice and big. And remember, the open dots are just for the first value in the table. All of those other dots are going to be regular, and even the closed dots are regular dots as well. So something that we haven't encountered before in the notes with these problems is what to do when there's an open dot and a closed dot on the same space. What I would like you to do is make the open dot big enough and around that point and sort of coming off of the line so I can tell which one it's going with, although I should be able to tell from your table as well. What's really interesting about this one is it does have a domain of all real numbers. It also has a range of all real numbers. There are no breaks in the x values, and there are no breaks in the y values at all. Those open dots and closed dots on the same spaces cover everything. All right, folks, do we have any questions on those ones? Because I think at this point I want to give you some work time just to practice the regular piecewise function. So go ahead and take out your purple packet. And you should be able to do number 31, number 32, and some of the spacing got a little bit awkward here. So 31 and 32 on page 6, 34, and 36. So you can do 31 and 32. And 33 and 36. The other ones are step functions, and we will regroup on those, I think, in a bit, but I want to give you guys some time to practice just the regular old piecewise functions first.